Just listen to me. Let I say observation, because I'm going to be there. Good day. I will use my case phone because I don't have space. Good afternoon, guys. I have my sample results. It has this. So I'm going to take a big tube, a test tube. I'm going to take a little quantity of this. Add it here. I have this. So this is a mixture of salts, we've been told. So I'll add a little quantity of water in it. You can observe clearly that, so I have to swirl a bit, and you can see all of it dissolved. So I'll write on my observation that sample C dissolves completely in water to give a pale blue coloration. Sample C dissolved in water to give a pale blue coloration. So in my inference, I'm going to say sample C is a soluble salt. And underneath, I'm going to say original solution formed. So I'll represent it with OS. So original solution formed because it's already dissolved. So I'll be taking all of my sample from here in case I'm asked to like divide into portions. So original solution is formed. So now we can be told to take a little portion of C. I'm going to take a little portion of C. So the question could be that we should add a little bit of sodium hydroxide, or you can be asked to test with litmus. So I'll test with litmus. So whenever you're asked to test with litmus, you test with both red and blue. You don't select the one you would want to use. So I'm testing with both red and blue. I'll bring them out. Make sure that's like a video. Make sure that it is showing, because it might stop working and you will not know. So I'll check with both red and blue. So I would add my blue to this. I'll try it here since I have more portion. So I'll try it here since I have more portion of the solution. Oh wow, that looks nice. You can see that the blue litmus turned red. So obviously we know nothing will happen to the red, but to clear doubts, because I'm trying to show you. So if we put it here, you observe that there was no change with the red, but the blue became red. So in our observation, we'd say that there was no effect on red litmus or sample C. Or remember, we have done original solution before. So on our, we just say OS plus this, OS plus litmus paper. So you don't have to indicate whether it's red or blue, but in your observation, you're going to write that it had no effect on red litmus, but blue litmus changed to red. So what that implies is that in the inference, you say sample C, the solution of sample C is acidic. Are you with me? Solution of sample C is acidic. So I'll go ahead. I wanted to do something before now. So I'll take this. This is sodium. Let's put this aside. This is sodium hydroxide. So I'm going to take a little of it. They said in drops. I'll put few drops. You can see what's happening. I can put in excess. You can see the blue. There is a deepening of the blue solution. So the blue observation, you notice, you say that blue coloration deepens. Blue coloration deepens, and if you look closely, you notice that there's a gelatinous pipette that is formed. So we can say a blue, and the color deepens, right? So the inference is that since it's sodium hydroxide, the inference is going to be that Cu2 plus suspected or present. Don't write confirmed because it's sodium hydroxide. So you can also be told to take a little more sample. So I put this, so I don't repeat it. Put it aside. So in drops, blue gelatinous solution formed for that sodium hydroxide. In excess, you write that the blue coloration deepens, or the white gelatinous PPT persists, or PPT remains insoluble. The blue coloration deepens. So I'll take a little more sample of this. Here. Down. So I'm going to add ammonia. This is my aqueous ammonia. So now if we have the same thing happening here, we should know that Cu2 plus is now confirmed. So if I add ammonia here in drops, you can see in drops blue PPT formed. In excess, blue coloration deepens, and compare. Look at what we had before. Can compare. Can see the difference here. So our inference is that Cu2 plus confirmed. For ammonia, Cu2 plus confirmed. So I'll set this aside. So look at this. So I can be adding this barium chloride. So a little bit of it. Can see white PPT. Can see white PPT. So if I put this, what did you notice? Which says here?
White PPT persists.
In SS, which is that white PPT persists.
Yes, sir.
Right?
Yes, sir.
So what does it mean? Now when you had added base Cl2 and we had white PPT, it means that SO2 2 minus, SO4 2 minus, S2 minus present. And when you add it in SS and it did not dissolve, and there was no effervescence, so you say no effervescence occurred, right?
Yes, sir.
In SS, and he put HCl. So what does that imply?
SO4.
That SO4 2 minus is present.
Yes, sir.
Right?
Yes, sir.
Are you getting me?
Yeah.
So that is it. Now, you can be asked to, I'm going to have a little bit of this. I'll be here. And I'll pour water. My phone, take it away from the light. I already have this. So, I have this. I can be asked to put phenyl A and phenyl B. It embarrasses me so much. You idiots. Phenyl A. Then phenyl B. Put the liquor for me on top of that and then put water instead. Can't see. The bit on top of it. Huh? Campus. As you can see that you're having a brick red precipitate. So what does that show you? That the reducing sugar is present. Are you getting me? You can see a brick red precipitate. Is science not beautiful? Like when you look at this, you know science is so pretty.
Oh, baby.
Yeah, baby. See? Can see the way it is. Very nice. So what does it mean? That a reducing sugar
is present.
is present. Or minus CHO functional. We can write it something.
Yeah. Any which choice.
Or you can even write glucose likely to attach everything.
It out alive, but I think I lost it. Said that I was fine, said it from my coffin. Remember how I died when you started walking? That's my life, that's my life.